Today we're going to talk about arithmetic sequences. You might have heard of them before, maybe not, and that's okay. So an arithmetic sequence is a sequence in which the difference between any two consecutive terms is constant. Okay. So again, a sequence in which the difference between any two consecutive terms is constant. Okay, common difference is the difference between any two terms. Probably should say consecutive term, but that's okay. So determine the common difference, then find the next four terms. So from 29 to 37, it looks like it went up 8, 35 to 45, 8, 8, 8. So our common difference here is 8. So then we're going to continue to add 8. So our next four terms, that would be 69, plus 8 again would be 77, 85, and then 93. So we're just continuing to add 8. Next one, it looks like we went down 3, down 3, down 3, down 3. So our common difference here, since we went down, is negative 3. And then continuing, it would be negative 22, negative 25, negative 28, negative 31. (25 to 11), that looks like it went down 14. If you're not sure, you can just subtract the second one minus the first one, which is going to give us negative 14. And then notice that pattern continues. So we're going to say D equals negative 14. Okay, and then if I continue, my next term would be negative 45, negative 59, negative 73, and negative 87. Okay, from negative 12 to 7, again, if I'm not sure, I can subtract, so I would do 7 minus negative 12, which is positive 19, which means each time it's going up by 19, and I can verify that with my other numbers. So then I'm just going to continue to add 19, so that would be 83, 102, 121, and then 140. The nth term of an arithmetic sequence can be found using the formula an is equal to d times n minus 1 plus a1, where a1 is the first term and d is the common difference. Okay, this n right here is your variable, so it should be in your problems unless it's asking for a specific number. Okay, so it says write a rule for each sequence, then find the indicated term. Alright, so I have 7, 13, 19, 25, 31. First job is to figure out what's happening and my first term. So my first term here, sorry, my first term here is 7, and then it looks like it's going up by 6 each time. So I'm going to fill in my formula. So I'm going to have AN is equal to my common difference times n minus 1 plus my first term, which is 7. I'm going to distribute, so it would be 6n minus 6 plus 7, and then I'm going to combine my like terms. So my equation is 6n plus 1. And then I'm going to do this last part here, which says a of 32. So this is one of your answers. It does ask for two things. It says find the formula and then find the indicated term. So I am going to plug 32 into this. So I'm going to do 6 times 32 plus 1, which is 193. So that is my other answer. For -7, -18, so my first term, A1, is 4. And then it looks like I'm going down 11 each time. So my common difference is -11. So my formula is going to be -11 times n minus 1 plus 4. Distributing that -11, I'll have -11n plus 11 plus 4. Combining my like terms, my equation is -11n plus 15. And then it wants me to find the 24th term. So this time I'm going to plug in 24. So I'm going to do -11 times 24 plus 15. And when I do that, I get -249. Go ahead and try the next two on your own, and then check them with the video. Okay, so on number 7, your formula should be 4n minus 27, and your 45th term should be 153. On number 8, your formula should be -2.5n minus 0.5, and then A39 would be -98. Use the information given to find the indicated value. Okay, so it gave us our first term and it gave us our d value. So we can actually just plug everything into our formula. We don't have to simplify or anything like, well, I mean, we'll have to simplify, but we don't have to simplify the formula. So I'm just going to plug this in. A of 36 is going to be equal to 7 times 36 minus 1 plus 29. And I can just type all that in my calculator at one time. And when I do, I get 274. Now this one's a little bit different. This one wants us to work backwards. So it says A22 is -156. D is -9. Find A1. Okay, so that means -156 is equal to -9 times, this is where that 22 comes in, 22 minus 1 plus A1. Then I just solve for my A1. So this will be -156 is equal to, I'm going to complete that. subtraction and multiplication, and I get negative 189. And then I'll add that 189 to the other side of the equation. So I'm doing negative 156 plus 89, which is 33. So I'm plugging in the information it's giving me and using it to find the missing term. All right, A1 is 11, A25 is 107, find D. So 107 is equal to D times n minus, sorry, not n. I know what n is, it's 25. 25 minus 1 plus 11. Okay, so this says I have 107, and this would be 24D plus 11. I'm going to subtract the 11 from both sides. I get 96 is equal to 24D. Divide both sides by 24. And I get that D is equal to 4. A1 is 5. A18 is negative 199. Find A13. So this one we're going to work in parts. We do need to, we'll find, looks like in this case, our common difference so that we know our formula, and then we'll plug it back in. Okay, so here I would say negative 199 is equal to D times 1 minus 1 plus 5. I shouldn't put 18, I'm sorry. 18 minus 1 plus 5. Okay, so that's negative 199 is equal to 17D plus 5. Go ahead and solve that for D. So first you would subtract the 5 and then divide by 17. And when we do that, we get D is equal to negative 12. Okay, so if I'm looking for A13, I can plug it in. This would be negative 12 times 13 minus 1 plus 5. And when I put that in my calculator, I get negative 139. AN is equal to negative 76, A1 is negative 21, and D is negative 5. Find N. So this will be negative 76 is equal to negative 5 times N minus 1 minus 21. I'm going to add that 21 first. So when I do, I get negative 55 is equal to negative 5 times N minus 1. You can distribute if you want, but I'm just going to go ahead and divide by negative 5. So I have 11 is equal to N minus 1. And then I just have to add 1. So I get that N is equal to 12. Okay, AN is equal to 310. D is 13 minus 15. So my first job is going to be to add that 15. So I have 325 is equal to 13 times N minus 1. I'm going to divide everything by 13. So N minus 1 is equal to 25. And then add the 1. So I get N is equal to 26. Okay, Okay, write an explicit and recursive formula for each sequence. So we talked about these before. The equations that we were doing on the front of this page are the explicit ones. Recursive is using the pattern that's happening. Okay, so it says, let's see, looks like we're going up by 2 each time. Yes? Okay, so for my recursive, I'm going to list my first one. So A1 is negative 19. And then what I'm doing is to find my next term, I'm going to take the previous term and add 2. Okay, the easiest way to do these explicit formulas on an arithmetic sequence where it's just adding or subtracting the same thing each time is to work backwards. So instead of adding 2 here, I'm subtracting 2. So I would say that AN is equal to 2N, because that's my common difference. And then what I got when I worked backwards. When I worked backwards, I would get minus 21. Okay, here, this one we're subtracting 6 each time. So my recursive, I'm going to say my first term is 37. My next term is the previous one minus 6. Okay, for my explicit, I'm going to say negative 6n. And then if I work backwards, I'm going to add 6 to this, which would be 43. So it's positive 43. Alright, so then we're going to talk about what's called an arithmetic mean. Okay, this is the terms between any two non-consecutive terms in a sequence. For example, given the sequence 2, 8, 14, 20, 26, 32, the arithmetic means between 8 and 32, so here's 8, here's 32, so the ones between them would be 14, 20, 26. 50 and 118, find the indicated arithmetic means for each set of non-consecutive terms. So 50 and 118, and it says there's 3 in between it. 1, 2, 3. Okay, so what that tells me is 50 is my first term, 118 is my fifth term. So I can kind of work backwards, doing the same thing I did before. So this is my first term, this is my fifth term. So I'm going to say 118 is equal to D times 5 minus 1, since it's my first term, and my first term, plus 50. Subtract that 50 from both sides. Sorry, just moving a few things around. But we're going to subtract 50 from both sides. So 118 minus 50, we're going to have 68 is equal to 40. So then, and then dividing by 4. So you have D is equal to 17. So then I can find those missing pieces by adding 17 each time. So this would be 67, and then 84, and 101. So it's kind of like we're working backwards. this time it says we're looking at 5 means, which tells us this is the first one, and there's 5, so that means this is the 7th one. Okay, so we have the first one plus 5, and then the next one would be 7. Okay, because I'm just not writing it out like this at the moment. Okay, so plugging it in, I would have negative 58 is equal to d times 7 minus 1 minus 16. I'm going to add that 16 over, so I'm going to do negative 58 plus 16, which is negative 42. This is 60. So that means, why did I write 48? I said 42. And then I'm going to divide both sides by 6, so I get that d equals negative 7. Okay, so then I'm just going to find them. So starting at negative 16, I'm going to subtract 7, so negative 23. Negative 23, negative 30, negative 37. Remember, I gotta find 5 of them. Negative 44, and then negative 51. Okay, I'm gonna say this is my first one. And then it says we're finding 7 means. So that makes this my 9th one, because I'm doing 1 plus 7 is 8. So the next one would be 9. So I'm going to say 5 is equal to d times 9 minus 1 plus 17. Okay, so I'm doing 5 minus 17, which is going to be negative 12, is equal to 8d. And then dividing by 8, I get that d is equal to negative 3 over 2. If you left it as a decimal, that's fine. Either way. So, whichever one you want. Y'all might prefer the decimal, so that's fine. Okay, so then I need to find those 7 numbers that are between them. So I have 17 minus 1.5, which would be 15.5, minus 1.5, which would be 14, minus 1.5, which is 12. 12.5 minus 1.5 again, which is 11, minus 1.5, which is 9.5, minus 1.5, which is 8, and then minus 1.5, which is 6.5. That's all 7 of them. I have to erase this though so I can do the next problem, so pause it if you need to. Okay. 2,265 is my first one, and 3,570, if I'm looking for 4 means, so 1 plus 4 is 5, so that means this is the 6th one. So 3,570 is equal to d times 6 minus 1 plus 2265. Okay, so I'm going to subtract 3,570 minus the 2265, which is going to give me 1305 is equal to 5d. So then divide by 5, and I get that d is equal to 261. And then I'm going to add that 261. So 2265 plus 261 is 2526, 2787, 3048, and then 3309. Okay, some application problems. A theater has 35 seats in the first row, 39 seats in the second row, 43 seats in the third row, etc. Write both an explicit and a recursive formula to find the number in the nth row. Okay, so what's happening each time? So 35 to 39 is 4, 39 to 43 is 4, so it looks like it's adding 4 each time. Okay, so if I'm adding 4 each time, my recursive, I would say A1 is 35, and then AN is my previous term plus 4. So that's the recursive version. To do the explicit, I'm going to say AN equals, again this is 4N because it's adding 4 each time, and then if I go backwards, subtract 4, that would be 31. Ryan weighed himself at the end of each week into his new diet. The table to the left shows his weight at the end of each week for the first 3 weeks of his diet. Write the explicit rule and find his weight in weeks into his diet. Then find his weight after 16 weeks. Okay, so we need to see what's happening here. To do that, it's going down, so we know it's negative. You can just subtract them. Looks like this is negative 1.7. Okay, so my rule, AN, is going to be negative 1.7N, and then I'm going to work backwards. I'm going to add 1.7 to that. So if I add 1.7 to that, I get 258. So that's the first part of my problem. The second part says 16 weeks, so I'm going to do negative 1.7 times 16 plus 258. When I do that, I get 230.8. Right. Last one. On Anna's first birthday, her grandma gave her a check to open a college savings account. Her grandma continued to send her checks on her birthday, each at the same amount. At 7 years old, Anna's grandmother had given her a total of $610. At 18 years old, Anna's grandma had given her a total of $1,270. How much money did Anna's grandma give her on her first birthday? Alright, so I'm going to say that this is the 7th year, and this one is the 18th year. So when I put this in, I might put it in a little differently. I think I'm going to put it in as 1270 is equal to, I'm going to do D times 18 minus 7 plus 610. Okay, so the first thing I'm going to do is subtract that 610. So 1270 minus 610 is going to be 660 is equal to, this would be 11D. And then I'm going to divide by 11. So that tells me that D is equal to 60. Okay, so So then I could find A1, so I could work backwards. I could start at 610 and just keep subtracting 60 if I want. I would prefer to do it a little bit differently. So I'm going to do it kind of how we did in those previous problems. I'm going to say, okay, well, 610 is equal to 60 times n minus 1 plus A1. And this, sorry, this n here is a 7, because that's our 7th term. Okay, so I'm going to find that first. So this is 610 is equal to 360 plus A1. So then I just have to subtract 610 minus 360, which is 250. But you can just go and subtract 60 until you get to the first term if you'd like. But that's it for arithmetic sequences. And that's it for your videos. So, yeah, I will see y'all next week. Bye.